Dear students, welcome to the video integration as the reverse of differentiation. My dear AS students, in this video we go for the last chapter of your pure mathematics, chapter 9, integration. Now, before we start integration, you need to know some prerequisite knowledge from IGCSE and previous chapters as well. The first thing that you need to know is that, for example, you learn in O level 1 when you are writing equation of a straight line, which is of the form of y is equal to mx plus c. In order to find c, which is constant, or y-intercept in other words, you just substitute the point in the equation as x and y and you find constant c. Or, you learned also in differentiation chapter, when you want to find, for example, constant in any equation, just you need to have a point satisfying the equation. So if you replace -1 in the equation and you have y as well, then you can easily find c. The other thing that you need to know is to find x-intercept. What is x-intercept? X-intercept is the point at which your equation cuts x-axis. So you put it equal to 0 and you solve it. For example, it's a quadratic equation. It can be easily solved by quadratic formula or factorization or completing the square method. The other one as well, you can do it by factorization. Radical x is a common factor. If you take out radical x, it would be radical x brackets 3 minus radical x. Then you put them in a 1 by 1 equals to 0. In chapter 7 also you learn how to differentiate. So here, for example, is polynomial. You know how to differentiate. It is as well, but in radical x it should be written as an index. How? Radical x must be written x to the power of 1 over 2. Then you differentiate. Power comes down and 1 is subtracted from the power. First, we need to know why do we need to study integration. In chapter 7 we learned that the first basic tool of calculus is differentiation. Now in this chapter you learn that the second basic tool of calculus is integration. Integration has so many applications. You see some of the applications here, for example, planning a spacecraft flight path or modeling real world behavior for computer games. So these are some of the applications of integration, but here we mainly use integration in our calculus in chapter 9 to find original function and also to find the area under the graph. Now, integration is actually, I told you when I started differentiation, integration is the reverse process of differentiation. When you differentiate, you get a new function. Now, when this new function which is obtained through differentiation, when it is integrated, you go back to the original function. So we are going to learn this thing here. For example, you know that if y is equal to x to the power of n, then dy over dx will be n to the power of n to the power of x, nx to the power of n minus 1. For example, if y is equal to x cubed plus 3, then plus c, sorry, when you differentiate all of them, if c is any value, any constant value, for example, in this case c is minus 7, in this case is positive 4, in this case is negative 59, in this case is half, in this case negative 0.1, here c is 0. But if you differentiate all of these functions, all of them become 3x squared, 3x squared, 3x squared. Why? Because differentiation of constant is 0. Now, so we learned that integration is reverse process of differentiation. Now, so let's see the formula of integration. If dy dx is x to the power of n, so we learned that differentiation subtract 1 from the power. So the power of n becomes is converted to n minus 1. Now integration is doing the opposite thing, adds 1 to the power. So when you want to integrate a function like x to the power of n, integration will be x to the power of n plus 1. N plus 1. So, but you are looking for a function when differentiated becomes x to the power of n. So let's differentiate this x to the power of n plus 1. We know that x to the power of n plus 1, when it is differentiated, n plus 1 comes down, n plus 1 cancel out each other. So it will become 1, as you have here. The coefficient is 1. And 1 subtracted from the power, so it will be n plus 1 minus 1, which is n. Why do we put plus c? Because no matter what your c is, whatever c is your constant, the differentiation constant is 0. That's why we put a constant here. But be careful, n should be a non-negative 1 number. Why? Because the denominator cannot be negative 1. In the next video, we go for more cases and more examples. Dear AS students, it is the second video concerning integration, chapter 9. In the previous video, we learned that integration of x to the power of n is x to the power of n plus 1 over n plus 1. Why we do so? Let me just explain. Because differentiation subtracts 1 from the power, so integration is reverse process, so does inversely and adds power. So I'm looking, integration means give me an expression or a function when differentiated becomes this. So let's see if it becomes this or not. When you differentiate this expression, n plus 1 comes down, then n plus 1 cancel out each other, so nothing remains here. As you see here, there is nothing before x to the power of n. Then subtracts 1 from the power. So if you subtract 1 from n plus 1, becomes n. And differentiation constant is 0. So after differentiating this expression, it becomes exactly this. So we are right. Now, there are some properties that you need to know. The first one is that, when you have constant k, constant can be brought out of the integration, as we do for differentiation. You ignore constant, you differentiate, then you put the constant in its own place. We can do the same thing for constant. And the second one, integration of addition or subtraction is addition or subtraction of integrations. What does it mean? It means that when you have two functions, you can separately integrate them. You can separately integrate them and add the results or subtract the results with each other. Now, let's see some examples. Example 9.1. As you see here, differentiation is x to the power of 3. You are supposed to find y. It means original function. So what was the formula? X to the power of n plus 1 over n plus 1. So n is 3 here. So it will be x to the power of 3 plus 1 over 3 plus 1. So it would be x to the power of 4 over 4 plus a c constant. We don't have enough information to find c. In the following parts, we will learn how to find c. Here, 1 over x squared, so bring it up. It will be x to the power of negative 2, then x to the power of n plus 1 over n plus 1 plus c. It will be this, negative x to the power of negative 1, which is, when you transfer to denominator, it will be negative 1 over x plus c. Here, x radical x, be careful, do not integrate them separately, it's multiplication. You cannot do so. First, combine them to make one single term. X radical x is x to the power of 1 over 2. It will be x to the power of 3 over 2. So 1 added to power, then over 1 over n plus 1 plus a c. Then you know how to calculate. Now, let's see some more examples. It says find f of x in terms of x for each of the following. Again, differentiation is given. You are looking for the original function. So here, for x cubed minus 2, it should be written minus 2 x to the power of negative 2 plus 4 x to the power of 0. 4 means 4 x to the power of 0. Yes? Now, 4 x to the power of n plus 1. So integration of 4x cubed will be 4 x to the power of n plus 1 over n plus 1. So n is 3. X to the power of 3 plus 1 over 3 plus 1. So it will be x to the power of 4 over 4, you have one constant 4 here which cancel out each other, minus 2. Here x to the power of negative 2, negative 2 plus 1, which is negative 1 over negative 1. Then you will learn, you will simplify them. So x is x to the power of 0, so x to the power of 0 plus 1 over 0 plus 1 plus c. Then the rest is simplification. Second example, 8x squared minus 2 minus 1 over 2 x4. x4 should come to the numerator plus 2x. So it will be 8x squared after changing the form. It is not integration. Be careful. You are just changing the form. So it will be 8x squared minus 1 over 2x to the power of negative 4 plus 2x to the power of 1. Then now I integrate. Now we continue part B after changing the form. So it will be x to the power of 2 to plus 1 over 2 plus 1. So x to the power of negative 4 plus 1 over negative 4 plus 1. So you have a constant 2. Negative 4 plus 1 becomes negative 3. You have negative 3 here. This 2 is this coefficient. Then plus 2 x to the power of 1 plus 1 over 1 plus 1. So x to the power of it is different integration, sorry. Then you have a constant 2 which is in its own place. Then you simplify 8 over 3 x cubed. So 2 times minus 3, you have a negative becomes positive. X negative 3, 2 cancel out each other. X squared plus sc. And last case, differentiation is x plus 3 times x minus 1 over radical x. I told you cannot integrate in this case. First, you should expand, which is expansion, x squared plus 2x minus 3 over radical x. Then you should separate them, x squared over radical x plus 2x over radical x minus 3 over radical x. Then simplify. Radical x means x to the power of 1 over 2. So x to the power of 2 over x to the power of 1 over 2. When you subtract powers, it will become this. 2x over x to the power of 1 over 2 becomes 2x to the power of 1 over 2. You know, you subtract powers. Then minus 3 over radical x. Radical x is brought to numerator. So it will become 3x to the power of minus 1 over 2. So now you are to integrate this expression. So x to the power of n plus 1 over n plus 1, x to the power of 1 over 2 plus 1 over 1 over 2 plus 1, x to the power of minus 1 over 2 plus 1 over negative 2 plus 1. And be careful, coefficients are in their own places. Then it will be integration, then the rest is simplification. Here you do far near becomes 2 over 5. X to the power of 5 over 2. Here you do far near. 2 is 2 over 1, so it will be 4 over 3. Then here, if you do far near, it will be minus 6. Now, another example. Here, you have 3 factors. Expand them, then it becomes this. Then integrate. So it will be x to the power of 4 over 4, x to the power of 3 over 3, x to the power of 2 over 2. And you have coefficients in their own places. Here, you should, it's a division, should separate them. For x squared, you should write 4x squared over x once, which becomes 4x, because x and x cancel out, x squared cancel out each other, one of them, minus 3 radical x over x to the power of 1 over 2, over x to the power of 1, you subtract powers, it simplifies to this expression, then you integrate. So it is the integration which is easy now. Now I would like you as homework to do 9A questions 1 to 5. Thanks for watching this video.